So, okay, what is Mathcad? Mathcad is a general calculation tool, and we often hear that many users in engineering use spreadsheets, and we try to tell them that there's a better tool. So let's have a look at a simple calculation. I used this last year. I found this thing on the other side of the street, a schoolyard, and I found out that it's called a frustum, and maybe it's not that complicated to do calculations around it, but I looked it up on Wikipedia, and I have a Wikipedia link here saying it's called a frustum, and I tried to find some sort of equation here that looks a bit complicated, so I settled for this one, the volume of the frustum. So what would that look like in spreadsheets, and what would it look like in Mathcad? So I've prepared something here. So this was the Wikipedia equation, and if I open it up in Excel, I have values here, and with units in other cells, and I have this equation. So basically in a spreadsheet, any spreadsheet, it looks something like this. And what we're saying is that this is not easy to follow. It's not easy to see if it's correct or not. Easy to do 2 errors. So what would it look like in Mathcad? I have that one here. Basically the same as when you write equations with special tools, or make pictures, or drawing it on the blackboard in school, or with pen and paper. So in Mathcad it looks the same. And in Mathcad, let's say, let me create some more space here. So we have this one in Mathcad, and I had some values as well. So if I try to calculate this one, of course I will get an error, because I need to have the correct keyboard settings. Now I've got Swedish keyboard. So I get an error. Mathcad is saying that it does not know what n is in this case. And here I think I would like n to be 4, because it's 4 sides of this one. So I just enter 4 there. And I want this bottom side here, called A1 in the picture, to be 135. I need to put in the A2 as well. That is 55 in my example. And now I can see that it's using the wrong H. I need to put my H in. It should be 157. What happened here was that there is a built-in constant in Mathcad called H, the Planck's constant, so it used that one. But I want my own H. So basically I get an answer here. It looks like a lot. Let's see. It's all in centimeters, and in a spreadsheet it really doesn't care about units. Even if I put things in here, it can't recognize that this is. So basically it's telling me here in my calculations that this was in cubic centimeters, and I recalculated it to get in cubic meters. So basically in Mathcad we don't do it like that. Instead we use units. So let's put in units here, saying this is centimeters. Now I get errors again because I need units on everything. Centimeters, centimeters. And it's presenting in the default volume unit, that is liter. But I can tell Mathcad, okay, I want it in square meters cubed, like that. So it doesn't matter if I choose to put the values in some other unit, like let's say 1.35 meters. That's the same. The answer will be the same. I can mix units as I want. And if I want the answer in some other unit, maybe in feet cubed or something, I just enter that. So this is why it's so easy to use Mathcad in engineering, because normally you have units on everything. And we can always see the calculations in a spreadsheet. It's not easy to know if this value, I need to click here to see the equation, but this one, no, it was just a number. But in a printout or when you look at it, you can't see the difference between calculated values or just plain numbers. Okay, that was a quick introduction to Mathcad and the differences between spreadsheets. So, but I want to go back to my agenda and start the sort of basic presentation of the details in Mathcad. But before that, maybe have a look at what can a completed worksheet look like. So my first example, an old worksheet called distributed load, some bending things. I think this is kind of a typical Mathcad worksheet. It's not that complicated, no complicated math, and it's only 7 pages. But as you can see, it's a mix of pictures and text in a free layout, and some explanations here in the beginning. And then in this case, it builds up with 6 parameters with units, kilonewtons per meter and kilonewtons and length in meter. And then we have the solution, the calculations, and we can see that it presents it with units afterwards, and more calculations, a few more pictures. I think we should have some graphs as well further down. There's a graph showing something that's hopefully interesting, and some sort of end of it all. So no advanced math, just plain math with integrals, things like that. And everything is live, so if I make a change here somewhere, say, okay, I want this to be 8 meters instead, everything is recalculated now with new results. So I think this is a good example of a typical normal simple Mathcad worksheet. If I want something more complicated, I have something that's made up just to show what we can do in Mathcad. So basically this is a short document with a lot of features. So here you can see that we can play around with colors and put in pictures. We can use programming, we can add tables, we can have a drop-down list called combo box in Mathcad. We can show Excel components. So if I change something here, maybe there's a recalculation saying which thing is a passed or failed, sort of a conditional formatting thing in Excel. I have an area with hidden things. Basically an example where most of the features are pulled in. Here's also examples on how we can use this in combination with, in this case, the CAD tool Creo. So this is an input variable to Mathcad, and we have also outputs, so we can communicate with other software. And some more graphs, and even more graphs. Yeah. That was how it can look when it's done. But now back to the simple example. So I've got a few things here. I just start walk through. So let's see some basic Mathcad. Let's move it to a page break like that. As you saw, we can use pictures in a Mathcad worksheet. I just click on this image, I can browse for an image, or I can just copy paste. But let's see my desktop there, images, grab a picture. We can move pictures around, we can change the size, but we can't create pictures in Mathcad. For that, you need to use a drawing tool of some kind. Of course, we want text in here. We can put in text boxes. So this is a text box, and let's see my text. I'm using Swedish keyboard. Okay, so if I put the spell checker on, it will tell me that I can't spell, but that's because I'm using a Swedish keyboard, so it thinks that I'm writing in Swedish. Text boxes, you can resize them, you can move them around. We also have a text block. Then it's more like in a word processor. This is a text block. And I can create more lines like this, just like in a word processor. Moving over to writing math in Mathcad, the key to success is to use the space bar a lot. So if I just want to type something 1 plus 2, I just use the keyboard. Maybe I want to divide this by 3, then I use the space bar to select and press the division. 3 space multiply by 4 plus 5 space again multiplied by 6. So it's really easy to write equations in Mathcad, and then you just press enter if you want to see the result. And you can, of course, you can copy paste, you can replace operators, clicking on this one, saying, okay, I want it to be a minus sign instead. And my equations from before, if I would like to type that in just to show you that it's fast. If you just learn a few things. So that was, I guess, n time h space divide by 12 space multiply. Let's put a parenthesis in, and I use a1. That's the 1 is just a subscript. This one in Mathcad, subscript. So it has no specific meaning, but it should be squared and plus a1 multiplied by a2 plus this a2 squared. And let's at the end multiply with cotangents. Pi divided by n. Divided by n. So yeah, so this is how easy it is to enter this one, and we can clearly see that it's typed in correctly. If we want to compare it to the one that I had in the Wikipedia page. Calculations in details. Let's see if I have this calculation. I don't have to type something in again. You can see that we always get the numerical result. If I make a change here, it will automatically recalculate. If I calculate something that we maybe normally don't see when in school, but of course Mathcad can use complex numbers, so it's not a problem. They end up in a lot of engineering examples. So, and if I type a complex number in myself, I can just see that it works fine. If we want more operators that we can find on the keyboard, I go to the math menu and look at operators. So let's see, let's take an example on an integral. Let's calculate from 1, 2, 3 for x squared dx, and I get the number. So really easy to do. And just to show a bit more advanced example, we have something called solve block. That's the Mathcad word for system of equations. So I just type a very simple system of equation. Let's put a circle in. Oh. Keyboard problems. X squared plus y squared equal to something. Then that must be a circle. Let's say 5. And put a line in. 2 times x plus 3 times y equals 4. And with a bit of luck, maybe this line goes through the circle and I will get an answer. It's a numerical algorithm, this one, so let's put guess values in. And just put a find at the end. Find x and y, and it's spelled find. X and y. I wrote it in the wrong direction. Find, like that, x, y. And if it finds one solution, there must be another one as well, I guess. So let's just test the other start values, and I found the second solution. Variables, move down, more space.
Magnus, I have a question here if you're able to take it now.
Sure.
Question is, I know we can highlight answers, but is there a way to do it automatically so that the color changes automatically if the answer changes?
Okay. Yes, I would say that before Prime 10 we could not do that in an easy way. Of course, there was strange workarounds, but in Prime 10 we got a new feature that I didn't plan to show, but let's see. It's in here. It's called advanced. It's called advanced controls. So here you can use a text box, and you can use scripts here, in this case a JScript, and put in something like an if statement saying it, if it's greater than 0, make it red, or otherwise green, or things like that. So I guess that's in Prime 10, that's the best or easiest way to do that. So I would say it's possible. But I was not planning to show any VB script. Maybe at the end, if someone is interested, we can. Please tell me and we can do it. Back to the basic features, variables. Of course, we want to use variables. In Mathcad, you just type the name and colon equals. That means a definition. Now A is 21, B is 45, and now I can use A and B in calculations. C is square root A squared plus B squared. C now is 49. We have something that's called an inline evaluation. So when I have this, I can evaluate this equation in the same region here. It's just me that I don't like that feature. So I normally use it like this. But when we have, if I use another variable, let's say A plus D, I will get an error saying, okay, D is not defined in this worksheet. And it doesn't matter if I put a definition here. It's not working there because it's in the wrong order, but A plus D here works fine. We also have an alternative. If let's use another variable, A plus F, I get an error, and then say F, and then I use a global definition. That means that it can only be defined once, and I can't change it in the worksheet. Of course, I can change it here, but I cannot do it on somewhere else. If I try to define F in another way, it will give me an error. Of course, we can use longer names than just one letter. So say that length is 23. Even put subscripts on our variable names, like length subscript inner 32, something like that. So it's a very flexible system. You can have really creative names. Maybe I should show you at least something about these controls, but because I think it was in version 7 we got the basic control called combo box. For those, you don't need any scripting, so they're much easier to use. So if I want to define something here, let's say some other value x, right click on this one, say I want this to be a list of things. Maybe I want it to be, I will use this later on, so why not call it metal? I will try to show that later. And we have a few metals and say a few values, 2.699 and 1845. That is beryllium. Just a few. I'll just put in 3 in here, just to show you that we can make something that looks like a menu. 935. What is the value for metal? Now it's this one because I choose copper. And you can also hide this, hide left hand side, or even collapse, so it's just a menu. Choose metal. Just to make it easier to use Mathcad, so basically restricting the inputs to a list of values. When doing calculations, of course you need functions. Some maybe you can just guess, say sine of pi. That's a very small number. Sine pi half is 1. So this was an example of where we clearly see that this is a numerical software. It's we're in math, we know that this is 0, and this is it's it's a very small number, so it's just some sort of rest. We have, and that's also on the list that was not planning to show, but in Mathcad we can do symbolic calculations using not using the equal sign, but instead using this arrow thing here, and then it will do a symbolic calculation and say that this is 0. So you get two calculation engines with Mathcad. But normally it's everything is numerical, so some natural logarithm and things like that. But you don't have to know the names. You can, of course, go to a tab called functions and maybe even list all the functions. So here's all the built-in functions in Mathcad. So if I want some trigonometric, I want to find the cosine of pi divided by 4. And of course you can build your own functions. If I want a function called f of x, simple polynomial. Now it's defined. Why do I get an error? Already been defined globally. Okay, it was this example that messed things up, so I call this ff instead. F of this one, f of 3, f of 19, or whatever, f of 2 plus 5i. So it's easy to create your own functions. And I guess I would recommend, if I use that volume function, where is it? Here is it. Copy. That would be perfect to use as a function. So let's put a definition in front of it, calling it the vol of n h a1 and a2. So now I have this one, and I can just enter values in here. Let's put 4, and now I can't remember the values I used before, but maybe it was 135. No, 157, 135, and 55. I'll be getting the same answer if I want it in meters. Moving on, vectors and matrices. That does not mean it's only for people using vector and matrix algebra. In Mathcad, if we want to compare it with spreadsheets, where we put the numbers in cells, we need to do that in some way in Mathcad, and then we use vectors and matrices. So, and there's a setting I should show first, calculation origin. So this means that the number of the first column and the first row is 0. I can change that to 1, or in Mathcad I can change it to any number, but any integer. But I use 0. So let's create a vector. Matrices, that's a small one. So now I have a vector with 3 elements. I can bring out the first one with index 0. I can create the vector. Let's call it W3 equals 99. Now I've said that the fourth element should be 99. So now I've created vector with zeros and 99 on the end. And the same for matrices. let's, okay, maybe I should use the tool and not that many shortcut keys. So now I have a matrix. Now I can bring out rows or columns. Let's get the middle column. Let's try some matrix algebra. M times V should not works fine, but V times N give me an error. So Mathcad knows matrix algebra. And we have a lot of functions related to vectors and matrices. Vector and matrices down here. So basically you can find statistics and maximum and minimum and things like that, and use lookup functions just like in spreadsheets. Let's use a simple one. Let's see how many rows do I have in M. It's 3. My next step is a really nice feature. It's in Mathcad. It's called ranges. In programming languages, we mostly talk about loops. But let's say, as in a really simple example, let's say that y is -2. Then I can evaluate y to see that it's -2. But then I want to put a range operator in here. Range.
Magnus, we have a new question for you, if you're able
Sure.
to take it.
Sure.
Do you guys have temperature units? Some of our projects are from customers in the US and they use Fahrenheit, but we do everything in Celsius. So it's kind of a pain. I can
Understood.
see this helping us with that if we can show temperatures in degrees Celsius and Fahrenheit right next to each other.
Okay. That it's a bit. Let's say in a few minutes I plan to talk about units. So let's put this in as a reminder here, C and F, so I know what I mean. So I'll get to that later. Hope that is okay.
Yeah, that's
Ranges.
fine. Thank you.
Yeah. So ranges. Let's say I don't want it to be just -2. I want it to be a range of from -2 to something. Let's put in 3, and then you can see I get a list of values. So this is not a vector, even if it looks a lot like a vector, but it's not. So whenever I use y in a calculation, let's say 2 times y squared, I get 6 results every time. So in this case, it's only 6 values, but of course I can go to 3 millions and I get 3,000,003 results. That's maybe too much for a presentation. And we can also specify the step here. Here you can see it goes with the step of 1, but if I put a comma in here, looks like a number theory in math. -1.5, then I'm forcing it to take a step of a half. So then I have 11 values every time I use y. So it's a really nice feature in Mathcad. You can do simulation and you can create large data structures very easy. And yeah, maybe I can do that. Maybe I can use R as a row operator. So if I want to use this to create the matrix, I want numbers here, integers. Let's run from 0 to 20. Same for column, 0 to 20, and some sort of calculation. Let's say Z, R, C, and something that depends on R and C. Let's square this and subtract the same with C squared. So now I created a 21 by 21 matrix. When I have larger matrices in Mathcad, I get this, what do you call it, a matrix navigator, so I can browse around in the data if I want to. But normally I don't want to see large data structures. I know that it exists. It's not like in a spreadsheet we have to show it. It has to be somewhere. I know I have this set. It's not that big, right? It's only 441 elements. But why not view it in a plot instead? This should look nice in a 3D plot, just to be able to show a 3D plot somewhere in Mathcad. So in this case, a well-known surface. Let's put some color in it as well. Next, plots. Okay, so I started the plot thing with that. Maybe I should move it down there. Okay, I showed some 3D plot now. But let's have a look at the more sort of basic plots in Mathcad. So let's say I have a function, or I had a function above, I think it was called f of x here, this one. Math form, let's make it the yellow one here. Let's reuse that one. So let's say I want an xy plot. It's the basic plotting. I want to plot the function f of something. I probably don't want to use x because x has a value and it looks like a matrix, so I don't want to use that one. Let's use t, something that is not defined in Mathcad. Then I know that Mathcad will fix the data points for me. So in this case, so here's a plot of my x function. An easier example would be to use vectors. Just want to move away from the page breaks. So let's see. Let's create an x vector, small one. Let's put 1, 3, 5, 2 or something. And a y vector with some y values, 2, 3, 1, 8. My x vector as my x values, my y vector as my y values, and there's the plot. And if this was a school example, I would probably fix it, saying, okay, let's start in 0, take a step of 1, and at 10 on the x-axis. Why not the same on the y-axis? Like that. Maybe clearer show the points. Larger align style, that's dots or something. Yeah, so there's a few features that you can use with the native Mathcad plots. If you want more plotting features, there's something called a chart component in Mathcad. There we have many more features for setting size and fonts and colors and everything. And of course we can have multiple traces. I could put, I guess, both of these in the same plot. Probably will not look that good, but let's do it anyway. V. That part of the graph, it was not that fun. Maybe I can redefine f of x to something else. Sine x times x squared. Maybe I should look at the minus side. Yeah, I hope this shows that it's so easy to just test out things in Mathcad. Make it smaller. Make that one red. Trace there. Okay, units. And we already have a question on units. Okay, the temperature units, I guess they are the most difficult ones. So let's wait a bit in before doing that. But in Mathcad, we can always use units on our calculations. So let's say I have a 2 kilowatt charger and I got 230 volts. Then okay, I need, it works with a 10 ampere fuse, but not 6 ampere. So you can always use units in your calculations. And my example before with the volume, copy, paste. So in this case, this was in meter. Let's say that this was in centimeters and this was in centimeters. Then I get the result in units as well, and I can choose the unit of my choice in my result. And this is for everything, every calculation you can do that. So as I showed before, what would it look like with feet squared? And it's okay to mix units. And if you want to use a unit that doesn't exist, let's say for some reason you want this to be 55 centimeter, that would be 5.5 decimeter. That's a unit that's not built in. Then you can maybe somewhere that where no one can see it, say that decimeter should be a unit. And I use the global definition saying it's 0.1 meters, and then it works. So that's how you define your own unit. And you can mix units in calculations. 12-inch plus 45 centimeters minus 2 yard plus 56 meters. That's everything is in length, so it's internally converted to meters all the time. But you can't add 2 kilowatts to 230 volt. That will bring an error. These units are not compatible. Okay, temperature units. If you have temp equals, I guess, what is it here in Sweden now? Maybe 8 degrees Celsius. It's not that easy to type that ring we want, so I can grab it from the unit list instead. Temperature units Celsius. And then if I evaluate temp, I get it in Kelvin because Kelvin is the default unit for the SI system we're using. But if I don't want it in Kelvin, I can just delete Kelvin and say, okay, I want it in Fahrenheit. So, but just make sure to maybe in calculations use kelvins. It's a bit complicated. You need to keep track of units. You can't say temp plus temp here and think that you will get 16 degrees Celsius. It's definitely not. It's a lot more. Units Celsius. It's much more. So that's why they have added here. If I have, let's say, temp plus and then a change in temperature, so I can put in and put in Celsius there. So if it's a temperature change in Fahrenheit or Celsius, you need to use this as the unit and not just the unit. But if you're working in engineering areas with temperatures, you probably know all this. That was a bit about units. Then, even if this was about why Mathcad is a better tool for engineers than spreadsheets, we want to show that we can use Mathcad and Excel together. So it's really easy to read data from Excel files. We have a read Excel function. It's got its own wizard here I can browse for. And let's see, data. I have an old data file here. So let's call it data. So this is how easy it is to import data. It's only 162 rows and 2 columns, and I can format it to be decimal. So it's data from an old pulse watch I had. So this is the pulse and this is the altitude, hiking somewhere. And we can also for this you don't need Excel on your computer. It just reads Excel, and we have the corresponding write Excel as well. We have a lot of file access functions. Most of them has to do with pictures, image processing. But we can read. Where does the read start? Read binary files. Read comma separated values, read Excel files, read file, it's very flexible, read PRN for text files, read text for other types of text files. So it's we have quite a lot of features and the corresponding write features. But if you have Excel on your computer, then you can also use the Excel component, and that's a really nice tool. So let's just show a short example. Let's put just a vector here. I want to send this vector into an Excel object. So let's put an Excel component in here. And say that I want to use my A as an input. Let's say I want to start in cell B2. So starting in cell B2, enter the values in A. So it just enters those. Now I can double click on this and do things in Excel. This is some sort of test. Maybe this is January, February, March, and this is now. This is then just multiplying this down. Maybe even, as this is often used just to be able to have colorful output tables in Mathcad. So, and that just, where's the close? Okay, let's just close it like this then. And I can collapse it so I only see what I want to see. And it's live, so if I change anything in here in the vector, it will be recalculated. And I can also grab values from an Excel. So if you have an existing Excel sheet with data, you can grab specific values from it. Output expression B. Let's take the values from B2 to B4. B equals. Basically, I just used Mathcad, the Excel component, to multiply things with 2. Combo box. Yeah, maybe I said earlier that I was going to make it more complicated. This one, copy, just to show you that it's a bit more flexible than I showed you before. So here's choose a metal. I can put units in here, and I can put in more columns. Let's put a column. Maybe I want also to see the whatever it's called, the number for that metal. Now it was just called metal, right? Now I get both the number and the value, and the value I think was some sort of density, so it should be with a unit, and that unit should be kilograms per liter, I think, that this one. But in this unit placeholder in here, we can't put in equations, so I need to have something that's defined as a unit. So let's just define this as something. Kilogram per liter. And hide it somewhere. Copy. Paste. Variables undefined. Okay, it should be a unit. Unit, like that. Okay. So whenever I choose something here, I get 2 results, and one had a unit and the other has not. That was, I think, everything on my list, but then we also hope for questions. Finn, are you still there?
I am. So we do have some questions, but we're also quickly running out of time. Let's see if we can take a quick one. Okay, so this one is, you may have already shown this, and I missed it, but is there a way to get a second y-axis on a plot with a different scale of values?
Okay, that question might be from someone who used the older version of Mathcad where we could do that, but in this plots here, I have to say no, we can't. But then, as I said, then we can use this chart component, and in that one, let's just double click. I didn't want to show this, but here, let's see, you can add a second y-axis. So yeah, yes, it's possible with the chart component, but it's not possible in the built-in native plots in Mathcad. On my agenda here, I had at the end licensing, and that I guess that's for you, right? If they anyone, Finn, that's your area of expertise.
Yeah, I guess so. Well, Mathcad comes in basically 2 versions, or 2 types of licenses. Individual licenses that you just install locally on your PC, or floating licenses that can be shared between everyone in the company. And if anyone needs any licenses, we would be happy to send you a quote for any number of licenses. So, so please send us an email, and we'll make sure to make you a good deal.
And if you go to our website, you can see a download trial link and test things out yourself. And on Mathcad.com, there's a few example worksheets that you can download and see what you can do with Mathcad.
Great. Perfect.